Hello, everyone. So now we are on our third week of the hot mix asphalt labs. We're going to be covering the rice test, which gets us our maximum theoretical specific gravity, which is our GMM. And then we also have our bulking, which gets you your volumetric numbers, and especially your bulk specific gravity. And you can use these to determine all of your other volumetric things that are required in the report itself. So we'll jump in. The rice test is ASTM D2041, standard test method for maximum theoretical specific gravity and density of bituminous paving mixtures. Basically, the rice test involves removing all the air from a sample by way of vacuum, and the only way you can do that is dunking the whole sample you have underwater and trying to have all the water take place of the air. So that's the way that we do it. We put it in a bowl. You put your asphalt that's broken up into it, and then you fill it with water. You try and shake all that air out, and you're able to kind of do some calculations to figure out what the maximum theoretical specific gravity is. So if you have asphalt on a road and you compact it until there's zero air voids, like it's only asphalt, that's not going to happen. But if you compact it until there's zero air voids, that's what this maximum theoretical specific gravity would be. It's the highest specific gravity it's going to get, and you can use that value to determine air voids. Those equations are in the specification sheets themselves, so you can look at that. But I hope that makes sense on like what this test is doing. Yeah, the basic principle: divide the mass of the sample by the volume of the sample, excluding air voids. And then our next test will be where there are air voids in it. You just dunk the sample underwater, and then you try and get that SSD, figure out how much is being absorbed. And you'll see that in just a bit. So I hope you understand that. The equipment that you use in this test is you use just a normal balance. You use a pycnometer. I know we saw a pycnometer before, was a glass pycnometer. There's multiple different types. You can do a pycnometer in a flask, in the little glass thing, and we did in the aggregates lab, and you can do it in this bowl. There's probably a lot more that I don't know about. So it's just a bowl that we're filling up with water, where we know what the weight of it is in air, in water, etc. We also have a mechanical shaker, which is this thing right here. It's just vibrates back and forth to try and wiggle some of that air out. And then we have a vacuum pump that's off to the side, and this contraption just sucks all of the air out that it can, and then it will shake for 15 minutes. Procedure: you want to break apart a 2,000 gram sample of hot mix asphalt. This was our small can that we made and mixed. We didn't show it in the video, but that's what we do. And instead of compacting it, you mix it together, and then you let it sit out and cool down, and break it apart by your hand so that there's not clumps of like asphalt stuck together. And then you weigh the sample and pycnometer that bowl dry. Then you submerge the sample in water, about an inch or inch and a half in water. Then you remove the air, and this is adding water into the bowl to submerge it in the bowl itself. Then you remove the air through agitation and vacuum for 15 minutes. Determine the mass of the sample underwater. So what you would do is you just get that whole sample, dunk the whole thing underwater, including the bowl, and you're able to weigh the whole thing and then subtract how much the bowl is. Like, I know that probably doesn't make a whole lot of sense. You'll see it in this video. I just want y'all to kind of get a little head start on it, so you're not trying to catch up with the video. But we'll watch Jason at NCAT. He's going to explain it as Madison does the rice test for us.
SOT 209 is determining the maximum specific gravity of your asphalt mixture, also known as your GMM value or your rice value. For this test procedure, you must get a sample of loose mix and break it up into small particles. Specification actually says that the particle should be less than 1/4 of an inch in size. As you can see, the technician is breaking this sample apart as this test is ran on loose uncompacted mixture. After your sample has been broken up to cool down to room temperature, you are ready to begin the test. Once your sample has been broken up into smaller particles, then you want to take these particles and place them in your picnometer and get the dry weight of your sample. The method that we are showing today in this video is what we call the picnometer method, or as some folks like to call it, the rice bowl method. You can also perform the flask method if you do not have the picnometers in the lab. Once the dry weight is taken, you will need to add water to your sample. The technician is using water from the bulk bath to make sure the water is at the correct temperature, 25 degrees Celsius. You want to add enough water to your sample that is covering your sample by at least an inch. The next step will be to apply a vacuum to the sample to vacuum the air out of the sample. While the vacuum is running, you should also shake your sample to help remove some of the entrapped air. If you have a mechanical shaker, you can just let the shaker run the whole time. If your lab does not have a mechanical shaker, you can actually shake the sample by hand. If you shake the sample by hand, you need to shake it every 2 minutes. If you have a mechanical shaker, just let it run the whole time, which we apply a vacuum and shaking for 15 minutes. Your vacuum pump must get down to a pressure of 27.75 millimeters of mercury. Specification reads 27.75 plus or minus 2.5 millimeters of mercury. After the vacuum pump gets down to pressure, after 15 minutes is up, you will then release the pressure. Once your pressure is released, you can remove your picnometer and you will place it in the water bath to determine the underwater weight of your sample. Placing your picnometer in the water bath, you want to be sure that you ease the picnometer slowly into the hole. You do not want water to rush into your sample and maybe forcing more water or air into your sample. The vacuum pump has already moved all of the air out of your sample. Once again, we are determining the maximum specific gravity of your sample, so all air. 10 minutes underwater, your scale should balance out and you'll be able to take your underwater reading. Then you should have the values needed to calculate your maximum specific gravity or GMM value of your asphalt mixture.
So that's that test right there. Hopefully y'all could understand it. I know it was kind of loud in there. If you need more info on it, just let me know. We'll move to bulking. The ASTM is D2726, standard test method. test method for specific gravity and density of non-absorptive compactive bituminous mixtures. So the bulk specific gravity is a test is used to determine the specific gravity of a compacted HMA sample, and that specific gravity obviously is comparative to water. So like room temperature water, I think it's like 25 degrees or 23 degrees C has a specific gravity of 1.0. So that's what specific gravity is trying to compare it with. You're trying to determine the specific gravity of a compacted HMA sample by determining the ratio of its weight to the weight of an equal volume of water. It's a long sentence. Hopefully just the procedure helps you understand it a little bit more. The equipment that you use is a balance, a water bath, and a thermometer. This is what they can look like. Ours in that previous video is what we use. It's just a 55-gallon drum with a hole cut in it and some water in it and a side valve and a scale on top. So what happens in this is you have your scale. You can weigh your dry pill. Remember, we made our pill, so we're dealing with that now. So you'd weigh it dry, and then what you would do is you would submerge it under water, and this has a line running down to this basket, and so it's going to be reading the weight of it underwater, and that weight will be around 60% of what the like in air weight is going to be. So that's your submerged weight under there. And what's happening is the water starts to fill in some of the voids in the sample. If the sample was really coarse, that's going to have lots of pockets for the water to flow in and push the air out. If it's really dense and has a lot of fine material, it's going to be harder for that water to seep in. So we're able to figure out how much water seeps into this. What we do is once you let this sit for a little bit, you pull it out, you rub it on a damp towel so that you can get the surface water off. You weigh it again, and your weight will be maybe 5 to 10 grams more, and those 5 to 10 grams are going to be water that's absorbed into the voids where the air would be. So then you use that number and your maximum theoretical specific gravity to determine your air voids. So in that thermometer, you want your water to be 25 degrees Celsius is what the ASTM says. Why it's not 23, I'm not sure, but it's 25. So procedure, I just kind of explained it. You record your dry weight of the asphalt concrete pill, submerge the pill in 25 C water for 3 to 5 minutes, record the submerged weight of the pill, remove from water, record the SSD weight, use a slightly damp towel to remove surface water. So I just went through it for you before I read this. So now we'll watch the video real quick on how to do this.
So for Astro T166, this specification determines our bulk specific gravity or asphalt of our compacted asphalt mixture. The equipment needed for this test will need a bulk station and a scale. Also needed will be a thermometer to measure the temperature of your water bath, which is also needed, and a timer. The water bath temperature for this specification is 25 degrees Celsius plus or minus a half a degree. There will be 3 different weights that we'll take for this test. The first weight that we'll be taking is our dry weight. So for our dry weight, just make sure your scale is zeroed out, place your sample on the scale, and record the weight. After the dry weight is recorded, we will now determine the underwater weight. Place your compacted asphalt sample on the holder in your water bath and start your timer. The time underwater to determine your underwater weight should be 3 to 5 minutes. Keep in mind while your sample is underwater that your sample and holder should not be touching the sides of the water bath or dragging on the bottom of the water bath. If this happens to be the case, it will give you incorrect weights and will give you an incorrect GMB value. After your 3 to 5 minutes is up and your scale balances out, record your underwater weight. After you recorded your underwater weight, take your sample, and now we'll determine the SSD weight. To do this, you must place the sample on a dampened towel, lock your sample, and then place your sample on the scale to get your SSD weight. You need to use a dampened towel because we are trying to remove the water from the surface of the sample, but not extract the water from the voids of the sample. If you were to use a dry towel, you could possibly remove some of the water that are in the voids of your sample. So you should always use a damp towel for determining your SSD weight. The specification actually states that they consider a damp towel to be a wet towel that no more water can be wrung out. After you recorded your SSD weight, you have your 3 weights needed to calculate your volt-specific gravity of your compacted asphalt mixture.
That's it. Pretty simple. I want to go through this one more time because this is pretty much what your report, this is what your report is going to need big time to solve everything else. With your GMM and your GMB, your maximum theoretical and your bulking, you'll be able to figure out this number, your voids in your mixture itself, the total voids. We want to hit 4% for super pave, so make sure you go for that, not from any of these 4 values. It's not going to be a specific one. It's going to be in between. It could be up here if our mixes have lower air voids. If they don't have 8%, it might be lower down here. But so you come over here from 4, you go down, you find that 6.16. Make sure you don't just say it's like 6.1 or 6.2. Try and really estimate that. Since we know that's a 1 and that's a 2, you can estimate that somewhat. Then you use that optimum binder content and you make another graph, and your optimum binder content, you'll graph it against other values and figure out what your VFA, VMA, and dust percent are. And you can use the calculations to graph any of those points there. And that's theoretical, so yeah, don't copy it. The goal for super pave level 1, which is what we're going through, is air voids is equal to 4.0%. When they do it in the field, or when we do it in the lab, sometimes we say we want 8% voids, because what's going to happen is when you construct it, you're going to compact to 92% density, 92% compaction effort or something like that, and the rest of the compaction to get from 92 to 96, that's going to be the traffic just driving over it. But the goal, you don't have to list what I just said. You just know that the goal is 4.0% for air voids, and use that parameter to find everything else that you need to, and check for pass or fail in the requirements. You've also been given the gradation and like the specific gravity of some of the other materials, so use those as well. But just remember that that's what you use to find most of your stuff. Class notes from Dr. Leva and specifications that are on the lab folders in Canvas. They all have calculations and helpful notes for the assignment on how to do your scope, how to write your equations out, how to solve everything. And if you have any other questions, you can email Suri and myself, and we will help you out as much as we can, kind of guide you through this report. This one's not as long as the aggregate one, but it's still a decent one to do. So hopefully y'all are able to get it done in a timely manner. I think it's due 3 weeks from now. Don't take that for what it is. It's on the assignment itself. So thank you.